Hi class, welcome to another session on biomaterials. So we shall continue with other topics on our first unit. So in the last class, we discussed what are the properties of a biomaterial or what are the characteristics of a biomaterial. To build on that, there are two other properties of biomaterial apart from the ones that we have already discussed, and they are biodegradability and biotolerability. Now, some material get dissolved and when they come in contact with the body fluid, or they degrade when once they are in contact with the body fluid, and they do not release any toxin. They just get dissolved into products that are readily absorbed in the body, and then the body is happy, and the implant also doesn't last very long in the human body. One example is soluble sutures. If you take the example of a say a dental operation where people get their wisdom tooth removed, or if a person undergoes a major surgery such as the cesarean, where incision is made on the abdomen and then the uterus is also cut and then the baby is taken out. Now, the abdominal or the surface incision can be sutured using clips or nylon thread. However, if nylon is used inside to suture the uterus itself, because uterus has to be sewn, it's cut off in order to take the baby out. So, if the uterus has to be sewn and you use nylon sutures there, then either you have to leave the sutures in forever, or when you think that the uterus is healed enough, you have to make another incision to remove the sutures, which is impractical. So in situations like these, we use absorbable sutures, and one of the example is catgut, which is a plant-based polymer, cellulose-based polymer, which just gets absorbed in the body once the wound is sufficiently healed. The main point that needs to be taken care here is that the absorption rate or the degradability rate of the material that is being used for making these kind of applications should be such that it allows sufficient time for wound healing. By saying that, if my material degrades quickly and so quick that it is not given enough time for the uterus membrane to uterus to actually stick together, then the purpose of suturing is not solved. Therefore, these materials should be having the rate of degradation in these materials should be such that it allows sufficient time for wound healing. Biotolerability is that is the formation of a fibrous tissue around the implant in order to prevent the the body fluid to come in contact with the material surface and prevent corrosion. So these layers are formed due to chemical reaction. The implant is coated with certain chemicals, and once these chemicals come in contact with the human body, with the biological fluid, it forms a protective layer of fibrous tissue. So this protects, the chemical that is coated on the surface of the biomaterial is actually reacting with the body fluid and forming a protection layer, and that is biotolerability, which improves the acceptance rate of the implant, to be very precise. So now, classification of biomaterials. Now, biomaterials can be basically of four types. They can either be polymers, they can be metals, they can be ceramics, or they can be compounds. So polymers are usually low density material and they are very easy to fabricate. However, they have low mechanical strength, which means they get torn very easily. And certain additives that are added to the polymer, such as the oligomers, it can cause reaction and inflammation when it comes in contact with the body fluid. Now, examples of polymers are polyolefins, polyesters, polyamides, polyurethane, polyacetals, polyesters, rubber, and silicone. Silicone and rubber are widely used for replacing soft tissues. Some examples or some applications where polymers are used are cardiovascular implants, maxillofacial implants, replacement of soft skeletal tissues, contact lenses, and sutures. Now, the main property why polymers are chosen for these kind of application is that they replicate the characteristics of a soft tissue, and second, they have quite a lot of elasticity. So when they are subjected, when they need to be expanded, they can expand, and once the expansion force or the tensile force is removed, the polymer can bounce back to its original shape. That's why polymers are used for these applications. Metals, on the other side, are very, very dense, right? They are very rigid, they're very strong. They are so strong that they almost replicate a bone. That's why they are usually used in orthopedic load bearing and fixation devices, dental implants, because occasionally we use quite a lot of force to chew, right? I mean, we use different forces. For example, if you're eating something soft like a chapati, you don't chew that hard. However, if you're eating something like a toffee or a really hard thing which you're trying to chew, like one example is the sugar toffees that you get. You need quite a lot of force to actually break the material and then chew and eat, right? So force on the force exerted by a teeth varies based on the rigidity of the object, of the food that you're consuming. Excuse me. So again, these kind of the enamel of the teeth is very, very strong because of which it is facilitating these kind of chewing. It is facilitating chewing of hard food. So if you are to replace a teeth, you need something as strong as the teeth itself, and metals can match the strength. Again, they are good conductors, these metals, so you can use them for neuromuscular stimulation. So, the benefit of using a metal is that it has high resistance, high conductivity, and good wear, and it has got good shock absorption. If you are putting it in the weight bearing joint, you have to make sure that the implant doesn't crack or implant doesn't fracture once the person is actually putting their entire weight on the implant, or when they're running, or when they're jumping, or when they're doing any such activity that is putting a lot of load on the joints. So metals can definitely be a good replacement in these cases. However, they do have low biocompatibility. They are very, very. I mean, metals. We know that they are very reactive, right? So they can corrode. So corrosion is one of the possible drawbacks of using metal, because although the metal may not corrode or for a year or for 2 years, but over a period of time, it can corrode when in contact with the body fluids continuously, and that's why metals are some of the metals they are removed after a certain period of time. Again, the neighboring tissues around which the metal is are used to having a cozy, smooth, soft surface around it. So suddenly you're replacing it with a very hard, rigid metal. So the tissues might not like it. So there's a mismatch in the mechanical properties, and that can lead to certain inflammation. These are the disadvantages of using metals. Now, ceramics, you can use them for applications such as dental filling or having a coating of the dental implants. So, zirconia is highly used for dental application. You've got aluminum oxide, calcium phosphate, and hydroxyapatite. So, they're highly biocompatible, they are inert, corrosion resistance, and have high tensile strength. So sounds perfect, doesn't it? However, manufacturing these so-called perfect biomaterial is requires quite a lot of controlled manufacturing process, because of which the manufacturing cost is very, very high, and then they can the degradation that a particular metal ceramic undergoes when it is in contact with the body fluid cannot be controlled. So these are the disadvantages. I mean, they are quite used for filling bones, and they are hydroxyapatite is like very commonly used to replace the head of a hip implant. Composites are carbon-carbon nanofibers or white fibers or reinforced bond cements, which are some examples of composites that are used for biomaterial purposes. Strong, they're very, very strong and they're tailor-made. However, again, tailor-made strong sounds ideal, but they're difficult to manufacture. They're often used to make heart valves and bone cements or implants. So that's all we have time for today, and I apologize for the yelping dog. Thank you very much for attending the class. See you.